All right, guys, let's do some motion problems. As we do this, just know that I am watching Mississippi State beat down LSU, and it is very, very exciting. There are 5 minutes left. If I get excited or stop talking, that's probably why. So, there are these motion problems, okay? The most important thing in the equation that you are going to use the most often is that this distance equals rate times time equation, okay? And most often, distance is going to be in miles or kilometers, rate will be in miles per hour, kilometers per hour, and time is going to be in hours. So we have to be careful about that, okay? Units become important when we do these application problems, word problems. So this first one, in the morning, Maria drove to a business appointment at 60 miles an hour. Her average speed on her return trip was 50 miles an hour, and it took 1/5 of an hour. Nobody speaks like that, but it's kind of helpful because our units have to be hours. 1/5 of an hour longer because of heavy traffic. How far did she travel to her appointment? Okay, so we got to think. Her distance was the same, whether she was going to the appointment or coming home. Okay, so on the way there, her rate was 60 miles per hour, and her time was, who knows, right? It was just however long it took her. But on the way back, her rate was 50 miles per hour. And again, we don't know how long it took her, except that it took her 1/5 of an hour longer. Not 1/5 of an hour total. It took her t hours on the way there, and it took her t plus 1/5 hours on the way back. Okay? Distance was the same. So remember, distance is rate times time. Okay, so her rate times time on the way there is 60 times t. Her rate times time on the way back is 50 times t plus 1/5. These are equal. Okay, she traveled the same distance on the way there as she did on the way back. So we are solving 60t equals 50 times t plus 1/5. Okay, so if I distribute the 50, get rid of the parentheses. Okay, this gives me an equation with only t, so I can solve, get my like terms together, subtract 50t from both sides, divide both sides by 10 to get t by itself. Okay, and t is 1 hour. Okay, so t equals 1 hour. Good for us. Did we answer the question that they asked us? Oh, sadly no. They asked us how far did she travel to the appointment. Well, t equals 1 hour is how long it took, but it's not the distance in miles. So we go back up here and we remember that distance equals rate times time. Okay, on the way there, her rate was 60 miles per hour. Now we know that it took her 1 hour. So 1 hour at 60 miles per hour, she traveled a distance of 60 miles. Okay, and there's our final answer. So just be really, really careful when you do these that you're actually solving what it is that they're asking you to solve. Okay, that we're finding what they're asking for. Okay, let's talk about Fritz. Fritz drives to work, and it takes him 36 minutes. Okay, so that means that his time is 36/60ths of an hour. Remember how we talked about how important units are going to be. 36/60ths of an hour. But he also sometimes takes the train. And when Fritz takes the train, it only takes him 20 minutes or 20/60ths of an hour. We want the distance that he travels to work if the train is an average of 32 miles per hour faster than his driving. So when he drives, let's just call his speed D for driving. Okay, but when he takes the train, he goes 32 miles an hour, not 32 miles an hour period, 32 miles an hour faster, which means whatever his driving speed is plus 32. So again, distance equals rate times time. So we got 36/60 times d equals 20 over 60 times 32 plus his driving speed. All right, if you don't like the fractions, if fractions are not your friend, you can multiply both sides by 60. So all those fractionies cancel, which is delightful. 36D equals 20 times 32 plus D. I'm going to distribute the 20. I'm going to get out my handy dandy calculator so that I can distribute. And I get 640 plus 20D. I get the terms with a D by them, well, together, right? So I'm going to subtract 20D from both sides. Then get the D by itself. So it's going to divide both sides by 16. And I end up with R equals 40 miles. Oops, not R, D equals 40 miles per hour. Okay, so Fritz's driving speed is 40 miles per hour. Does that answer the question? No, because do they ask how fast he drives? No, they ask how far he goes to work, right? But remember, distance equals rate times time. We want distance. His rate of driving is 40 miles per hour. How long does it take him? 36/60ths of an hour. 36 minutes, which is 36/60ths of an hour. You multiply those together, okay, and we get 24 miles. Good? Good. Okay, 2 high-speed ferries leave at the same time from a city and they go to the same island. I wish I was on my way to an island. The first ferry, the cat, travels at 39 miles per hour. So the rate for the cat is 39. The second ferry, the bird, that's funny, travels at a rate of 28 miles per hour. In how many hours will the 2 ferries be 11 miles apart? So here's what is interesting. We don't want distance to be the same. In the last 2 problems with Fritz and Maria, distance was the same. Okay, but for these ferries, okay, distance is not the same. So remember, distance is rate times time. Distance is rate times time. Distance is rate times time. Okay, but we don't want these distances to be the same. Okay, in fact, we want them to be 11 miles apart. So since the bird is going slower, he's going to be 11 miles behind the cat. So whatever distance the cat has gone, we want to know when the bird has gone 11 fewer miles. It's going slower. The bird is trailing the cat by 11 miles. Okay, so we have D equals 39T. And D minus 11 equals 28T. But luckily for me, I know that I can plug in, right? We know how to substitute to solve equations. So we get 39T minus 11 equals 28T. And I can subtract 39T from both sides. And I get negative 11 equals negative 11T. Divide both sides by negative 11, and I get T equals 1 hour. And then I ask myself, self, have you answered the question that they asked you to answer? Yes, I did. They asked me about time, and I found an answer in units of time, in units of hours. Good for me. Way to go. Okay, we have one more motion question. I'm sorry to disappoint you. Only one more. Jane, it's about Jane. Jane took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed, it took her only 10 minutes. The current in that part of the river is 3 kilometers per hour. What was her boat speed in still water? Okay, so Jane going upstream. Okay. Her time is 20 minutes, which is 20/60ths of an hour. Her speed is her rate, her regular boat rate, minus 3, because she is working against the current in the river. Okay, the current in the river is going 3 kilometers per hour. She's going upstream, so she's going a speed that's 3 fewer than what her actual boat speed is. Hope that makes sense. Downstream, however, right, she's flying. It only takes her 10 minutes or 10/60ths of an hour, but her speed is r plus 3 because whatever speed her boat is going, she's getting an extra 3 kilometers per hour because she has the current in the river working with her instead of against her. So distance equals rate times time. Okay, same distance up and down the stream. So we have 20/60 times r minus 3. And over here we have 10/60 times r plus 3. Okay, and this is just like Maria on the way there and on the way back. Okay, we've got the distances being equal, so we're going to set these the same. If you don't like the fractions, you can multiply both sides by 60. 20 times r minus 3 equals 10 times r plus 3. Okay, so 20r minus 60 equals 10r plus 30. So I'm going to get my r terms together. I subtract 10r from both sides. I'm going to add 60 to both sides, and I get 10r equals 90. Divide both sides by 10. So that means that r equals 9 kilometers per hour. Okay, so in completely still water, she would be getting a boat speed of 9 kilometers per hour. So then we ask ourselves, is this what we were asked to find? Her boat speed in still water? Why, yes. Why, yes, it is. Good for us. We are done. Okay, so there you go. There's your motion problems. You will have a total, like I said, of 3 videos. So you've got area perimeter, motion problems, which is this video, and you've got one more that is motion problems. I hope this helps. If I went too fast, just rewind and watch them again or pause them if you need to.